Alright guys, we are doing vector, we are doing vector value functions, integrals now. So trying to take integrals of these vector value functions. Some of the wording is pretty tough. Again, here the position of a particle on the xy plane is given by x at t, y at t, and then they say where they give you dx dt and dy dt. So they're kind of giving you the derivatives of those functions. Remember how our notation would be x of t, y of t. So what they did is they did the derivatives and they got that. We want to go backwards. We want to go and get the position function. So they give you a couple things. This is the position at time equals 3. So 2, 7 is the position at time equals 3. Just remember, like if you're plugging in, so if we plug in 3 to that position, you would get 2. And if you did the same thing here with 3 with the y, you would then get 7 as your vector. So that's what we want to use, is that vector with the time. And that's how we're going to find this, but you're doing 2 integral problems in one. So really just take, for x of t, take the integral of dx dt with respect to t. So we'll have t sine. Alright, so this one is a u sub. Good review of u sub. Your u, right? You're always making the inside part. Du, take the derivative. And you could see that this has, we could rearrange it where this has t dt. T dt, so maybe solve that for t dt, so we could just sub in. So you have du over 2 pi equals t dt. Now with our substitutions, you would have sine u, and then times du over 2 pi. Bring that out, and over 2 pi. And we wind up getting negative cosine. And then plug back in your u. Okay, and then from there, my notation, horrible notation. And then from there, we're using this point at time equals 3. So we are plugging in 3 for t. And setting it equal to your x coordinate, so that's 2. And then you're solving for c. So here, this is cosine 9 pi, which we know any pi of cosine is going to be 1, but it's an odd, so it's going to be -1, so this winds up being 1 over 2 pi equals 2. So we got 1 over 2 pi plus c equals 2, and then c equals 2 minus 1 over 2 pi. So then that would be your c for here. So we got x of t equals -1 over 2 pi cosine pi t squared plus 2 minus 1 over 2 pi. So it looks like that. And then, unfortunately, we have to do 2 of these. So let's go back up. And let's look at this one here. So for dy over dt, right, you're looking for y of t dt. So just take this function Okay, so again, another u sub. Remember, oh, that's not good. There we go, make your inside your u. So here we get u to be 3t plus 1, du is just 3 dt, so solve for dt. Substitute in. That's going to give us 10, and then du over u squared, but if you don't like it that way, u to the negative 2 du. And then anti is going to be negative u to the negative 1 plus c. So we have y of t, plug in your u. It looks like that. So we go back to our point, 2, 7, when t is 3, 2, 7, when t is 3. So y of 3, plugging in 3. Setting is equal to 7, and then solving. So we got negative 10 over 10 plus c equals 7, so negative 1. C is going to be 8. So now your function looks like y of t negative 10 over 3t plus 1 plus 8. And I was just plugging it back into there. So now you have these two functions, and if you go back, what are we looking for? This vector, and then you just write it negative 1 over 2 pi and there you go. So that's integrals with vector value functions. Tough, but manageable, just a lot of steps.